Q is how can you use scale drawings to solve problems, and scale drawings and scale models are used to represent objects that are too large or too small to be drawn or built at actual size. The scale gives the ratio that compares the measurements of the drawing or the model to the measurements of your real-life object. The measurements on a drawing or model are supposed to be proportional to the measurements of the actual object. And it's important that they're proportional, otherwise it's going to look somewhat like, if you've ever seen those funhouse mirrors where things are stretched out too much or they're squashed down too much. So it needs to definitely be proportional. And that goes into similar figures. The map is considered to be a similar figure to the real life object as long as they are the same shape with the same proportions, but they don't have to be the same size. A map is not the same size as the actual item that it's showing. For example, a map of Tennessee is the same shape as the state of Tennessee. It's the same proportionally as far as the length compared to the width, but they don't have to be the same size. The map of Tennessee is obviously going to be smaller than the state of Tennessee itself. So we're going to look at a few maps right here. On the map of Arkansas shown, find the actual distance between Clarksville and Little Rock and use a ruler to measure. And you can see down here is the scale. And it says that 1 centimeter on the map represents 20 miles in real life. And if I measure the distance between Clarksville and Little Rock, I'm going to use my ruler. And I'm going to use the centimeter part of the ruler. And it looks like it's about 4 centimeters long. And what we're going to do is we're going to set up a proportion. And the first ratio in your proportion is going to be your scale, and then the second is going to be what you're looking for. So my scale is 1 centimeter is representing 20 miles, and I have 4 centimeters, and it represents how many miles. So we've got the map amount on top, the real life distance on the bottom. And you can solve this with cross multiplication. 4 times 20 is 80, 1 times x is 1x, which is the same thing as just 80 equals x. So that means that they are 80 miles away from each other in real life. Now we're looking at a map of South Carolina, finding the distance between Columbia and Charleston. Again, look at your scale. This one's using centimeters again. 1 centimeter equals 27 miles. And they look to be about 3.8 centimeters apart. Remember, your first ratio is your scale. 1 centimeter equals 27 miles. 3.8 centimeters equals how many miles? Let's cross multiply again, and we'll use a calculator just to help speed things along. On my calculator, I'm going to multiply 27 times 3.8, and that gives me 102.6 is equal to 1x, which just means 102.6 equals x. That means they are 102.6, about 103 miles away from each other. And then Hollywood and Sumter. Hollywood and Sumter on here are about 2.93 centimeters. Just to make life easy, we'll go ahead and say they're 3 centimeters away from each other. Your scale is your first ratio. 3 centimeters equals how many miles? And this one, if you want to cross multiply, you can, or you can do what we've done before. 1 times 3 is 3. 27 times 3 is 81. They're about 81 miles away from each other. Now we're going to talk about scale factors. A scale written as a ratio without units in simplest form is called a scale factor. Now the thing you have to know about scale factors is they have to have the same unit of measure. And that means that if, for example, this one is talking about a sailboat, has 1 inch is equal to 6 feet in real life, they both have to be turned into inches. And we know that there's 12 inches in a foot, and you can say 1 inch in the scale drawing represents 72 inches in real life, and that just means that the scale factor is 1/72. If we have a model car where 1 inch in the model car represents 2 feet in real life, we need to turn both of these into inches. 1 inch represents, there's 12 inches in a foot, 1 inch represents 24 real life inches. Get rid of your units of measure, and the scale factor is 1/24. And then the next one, we've got ourselves some practice from example 1, and then we've got some practice from example 2. Example 1 was just setting up the proportions. On a map, the distance from Akron to Cleveland is 2 centimeters. What is the actual distance if the scale shows 1 centimeter equals 30 kilometers? Your scale is your first ratio. And we know they're 2 centimeters away on the map. How far away are they in real life? You can just multiply by 2 or use cross multiplication. They're 60 kilometers away in real life. And this one, the engineer makes a model of a bridge using a scale of 1 inch is equal to 3 yards. If the actual distance, this time they're giving us the real life distance, 50 yards, goes on the bottom, what's the length of the model? I'm going to use cross multiplication here. 3 times x equals 50, divide by 3, and again we're using calculators to speed things along. That equals 16 2/3 or 16.6 repeating inches. And make sure you know that it is inches because this time we were looking for the length of the model. Alright, let's go back to some scale factor problems. Some example 2 problems. Right here we have to turn this centimeter meter information into all centimeters. Well, I do know that there are 100 centimeters in a meter. So let's go ahead and turn this into 1 centimeter, and here's how I know that. Kangaroos hopping down little green mountains, drinking chocolate milk. To go from centimeters to meters, there's 2 sections away, 2 decimal amounts, and that's 100 then. So if I know that 1 centimeter equals 3 meters for real life, then I could say that I'm going to multiply that times 100. And that's 1 centimeter is going to represent 300 centimeters. 1 centimeter in the model is representing 300 real life centimeters. And that means the scale factor is 1/300. And then it wants us to find the length of each model also. That goes back to that example 1 that we were doing. The scale right here. And then it's saying that it's 36 meters tall in real life. How tall is it in the model? When we cross multiply, half of 36 is 18 equals 1.5x, and 18 divided by 1.5 is equal to 12 centimeters. So this is 12 centimeter model, and then the scale factor is 1 centimeter represents 300 real life centimeters. Alright, on this one again, we're going to take, for the scale factor part, we need to take inches and feet and make it all inches. Well, if 2 inches represents 15 feet, what I could do first is turn this into 2 inches represents 15 feet times 12 inches is 180 inches. And then our first number has to be a 1, so divide, and I get a scale factor of 1 to 90. Now, to actually find the length of the model, that's that example 1 that we did, the cross multiplication. I'm going to set up a proportion again and cross multiply. 2 times 87 is 174 and 15 times x. 174 divided by 15 is 11 and 3/5, or 11 and 6/10 inches. And again, we're using calculators for this to help speed things along because we've been practicing with numbers. Right now we're more concerned about setting the problems up correctly as opposed to actually the calculation part. So remember, the scale factor is different from finding a missing link. Scale factor is dealing with making everything the simplest form, same unit of measure. So this one became inches, and this one became centimeters, and then this one also became inches. And the first number is a 1. Alright, last page, we've got this floor plan for a home. 1/2 inch in the blueprint represents 3 real life feet. What is the actual area of bedroom 1? They had to find the length and the width of bedroom 1 using cross multiplication like we've been doing, and then area is length times width. And we're going to find the actual area of bedroom 3. You look for bedroom 3, you're going to find it over here. 1/2 of an inch, remember, is equal to 3 feet in real life. And if you look at the width right here of it, we've got 1 whole inch. And if I multiply a 1/2 times 2, I get a whole. And 6 feet is going to be the real life width. Now let's find the real life length. We're still using that same scale of 1/2 of an inch equals 3 feet. And the length is 3 inches. 1/2 of 6 would give us 3 inches. So that means I need to do 3 times 6. Wait. Am I setting that up correctly? Yes. 18 feet. And that's the real life length. And it wants us to find area. Area is length times width. That means we would do 18 times 6. And that's going to give us 108 square feet for the area of bedroom 3. Julie is constructing a scale model of her room. We've got 10 1/4 inches by 8 inches, and 1 inch represents 2 feet of the actual room. That's the scale. And it wants to know the scale factor and then the actual area of the room. Let's do scale factor first, and then we'll find the area of the room. Scale factor means that we need to turn both parts of this into inches. That would be 1 inch is equal to 2 feet is 24 inches. And cancel out your units of measure. The scale factor is 1 to 24. 1 inch in her blueprint drawing represents 24 real life inches. Now to find the area, if we've got 1 inch is equal to 2 feet, and we've got 10 1/4 inches for the length, we could do 1 times 10.25, which means we have to do 2 times 10.25 for the real life length, and that would be 20 1/2 feet for the real life length. For the real life width, we got to do 1 times 8 to get 8, and 2 times 8 is 16 feet in real life. To find area, we just have to multiply 20 1/2 times 16, and that's going to give us 328 square feet. And then our last problem. A model of an apartment is shown where 1/4 inch represents 3 feet in the actual apartment. Find the actual area of the master bedroom. So we're looking over here. If we know 1/4 inch represents 3 real life feet, what would 3/4 of an inch represent? If I do 1/4 times 3, that would give me 3/4 of an inch. And then that means I do 3 times 3 to give me 9 feet for the real life width. And if I know I've got 1/4 of an inch representing 3 real life feet, but I have an entire inch long length, 1/4 of 4 would give me 1, and 3 times 4 would give me 12, and that's my real life length. to get the entire area, I just multiply length times width, and my entire area is going to be 108 square feet.